So welcome everybody. Hope you're having a great Tuesday afternoon. I'm really glad to be joining you today on this webinar. We're going to start out the webinar. I'm just going to provide a bit of background for folks who are new to this project, just to give a bit of background for the rationale and why we were interested in advancing this project. And then also I'm going to turn it over to Brendan from AES Engineering, who's going to do it's going to take about 25 to 30 minutes or 20 to 30 minutes to do a presentation on the high level results that came from the EV costing study. And then we really want to dedicate a lot of time to better understanding the questions you have, and then give you a little bit of insight into the next steps. Now that the costing study is done, what are the next steps that we're going to be advancing as part of this project? So just wanted to give you a little bit of a sense of the agenda, and I will turn it over to, I'd like to kind of do a land acknowledgements. Really thankful to be able to be joining you here from the traditional lands of the Mississaugas of the Credit, the Anishinaabe, the Haudenosaunee, and the Wendat. And one of the things that I always been trying to do is learn a little bit more. And one of the things that stories I wanted to share with you that I thought was really a really interesting story is the dish with one spoon wampum belt. And one of the areas I was learning about it is that it's actually serves as a bit of a traditional treaty, and there's stories that are told in every single wampum belt that I thought was really quite fascinating. It's got a longer history with indigenous people in North America, all over North America, and there's different types of wampum belts, but it certainly predates European contact in North America. And one of the things I liked the most about this was that it's kind of serving as the treaty, and as you're holding on to the wampum belt, it really does it's almost like a truth teller. You have to tell the truth when you're holding the wampum belt. And all the participants in the agreement, the responsibility falls to the person who, when they're holding the wampum belt and sharing it in engagements and kind of relationships that they're building across different tribes and groups, that they would actually require the wampum belt had a truth telling ability to it that would, force call upon everybody holding the wampum belt to be honest and truthful with their words. And one of the things I loved the most about it was that it also is called the dish with one spoon, because it was recognizing that we are all eating from one dish, and we all are dependent on one dish, which is the earth that we all rely on for our livelihood and subsistence. But I liked also the fact of the spoon, because we all need something to kind of enable us or to be able to partake in our subsistence. But instead of actually kind of identifying the possibility that a fork or a knife could be used as a weapon, that's why it became the dish with one spoon, is that the spoon is that we all share the spoon, we all eat from the same bowl, and a spoon is something that can't be used against one another. Because we can't be going against one another when we are trying to care for it. And I thought that was a lovely, I really appreciated that story, and I just wanted to share it with folks as I try and learn a little bit more about Indigenous history that I unfortunately wasn't taught in school. So I just wanted to kind of share that story as well. I'm going to give a bit of background. The Clean Air Partnership, we're a charitable environmental organization. We work with municipalities and their various partners to help them reduce greenhouse gas emissions and increase the resilience to extreme weather and make advancements towards a low carbon economy. One of the key ways we try and advance that goal is that we get municipalities sharing with each other. So as each one of them undertakes a clean air or climate change action, we get them to share what they've done with all the other municipalities. And then we ask, okay, if one of you could do it, what would stop all of you from doing it? And then based on all the issues and barriers that have been identified through the collective brain power, we try and pool resources and try and advance them collectively, because we just don't have the time nor the resources to try and do this in isolation. And it's just a lot more fun to do this together than it is to do it alone. So in terms of the story, how this kind of began, it began about over 2 years ago. And one of the areas that we had, the Ontario Building Code had EV charging requirements in it prior to, I think, it was prior to the end of 2018, when they were removed from the Ontario Building Code. And when that happened, municipalities were asking and trying to understand what are the avenues available to them to understand how they can ensure that their communities do not fall too far behind on EV readiness and uptake. And one of the key things that municipalities were raising is like, what are the mechanisms and what are the opportunities for us to address EV readiness and uptake within your community? So one of the first things we did as part of this effort is we reached out to the development community and some of the partners that we have there to really understand what was their concerns with the EV charging requirements in the Ontario Building Code. And one of the first stories that we heard was that energy sharing wasn't part of the Ontario Building Code, and that was an issue because it did create an onus on the part of the energy management or the energy, the electricity allocations, that if energy sharing isn't part of it, that would really increase electricity allocations because of the load not being shared across a number of different circuits. And that really did put some concerns on the part of developers for the electricity allocations that would be required as part of the building, and the cost associated with that, and also the kind of overemphasis on infrastructure. So those were some of the concerns that we heard at the first. The other one was that load management was also not considered as part of the OBC requirements. And it's not like it wasn't considered, it was just that the electrical safety code didn't have energy sharing as part of its code at that point in time, and they did update it post the incorporation into the Ontario Building Code. So there would have been the opportunity to bring in energy sharing, but instead the OBC requirements removed EV requirements from the OBC. Again, that was kind of highlighting the electricity allocation of 100 to 200 amps. That was one of the concerns with regards to the cost and the increased infrastructure that we would require. One of the key areas that they also mentioned is in commercial entities, not knowing which chargers to use and how they would kind of set the structure up. It was a new world, and there were some concerns associated with that. The other thing that we heard also from the developers was, what's the future of EV charging going to look like? We can't kind of read into the future. And chances are, one of the things we've heard back is that they thought, well, there's going to be some sort of commercial charging entity or kind of business model created, and that'll be able to meet people's EV charging needs. And one of the things we did as part of that is truly understanding, do some research based on market research of electric vehicle owners and would-be electric vehicle owners to truly understand how important is at-home charging to the uptake of electric vehicles. And there was no doubt about it that even when we know that there's future business models on electric vehicle charging that are going to come into the market, the at-home ability to charge your vehicle is a huge impact, makes a huge impact on whether a person uses an EV or chooses an EV or chooses a conventional internal combustion engine. So even if there probably will be commercial EV charging business models and companies that provide that service, the at-home charging components is something that the market really desires. So we wanted to kind of understand that aspects of it too. So based on some initial consultations, when we put the proposal into TAF to try and understand what were the kind of main issues that people were considering and what were the kind of issues that we needed to address, Some of the key initial consultations with stakeholders that came out is municipalities were asking themselves, what kind of guidance will we need to provide? What kind of mechanisms are available to us to secure EV ready requirements? Two of the main mechanisms that came into play are the green development standards and site plan controls. The other one was in parking requirement bylaws. They wanted to understand a little bit more of the pros and cons of different mechanisms, and particularly what did it cost and what do we need to kind of take into consideration. So those were some of the main issues and questions that we heard from municipal stakeholders. From the developer stakeholders, one of the key kind of questions that came out to it is, what does it cost and what does it mean for electricity allocation? And how will it impact electricity deposit systems that are in place when they are required? And we will go a little bit into this as well, but I did want to kind of raise the electricity deposit structure. It is something that was completely new to me as I got into this. And I was like, okay, I'm learning new things all the time. But one of the key things that is of particular interest to the developers is that the developers work with their electrical engineers to determine what is the electricity requirements of the building itself, and look at it from the peak electricity needs. How much electricity allocation is this building going to need if everything is running all at the same time? And that's the peak electricity needs of the building. They then take that electricity allocation and report and then submit that to the utilities. The utilities review that report, identify if they are able to provide that electricity allocation for that building with existing infrastructure, or if infrastructure upgrades will be required in order to meet that building's peak electricity needs. If infrastructure upgrades are needed to provide that electricity allocation to that building, then there is a deposit structure in place where a certain amount of money goes into an account in escrow for a period of 5 years. And if that electricity use materializes, then that deposit will go back to the developer. But if that electricity use does not materialize, then that deposit goes to the utilities. And there's a formula for it, but I won't pretend to understand the formula, but there is a formula associated with how this is costed out. If that electricity use materializes, the utility will determine that the electricity use is actually paid for the infrastructure, and then the deposit will go back to the utility. There was a lot of questions with regards to how do we allocate for electricity allocations on EV charging, and knowing that EV charging will not materialize in the first 5 years, how do we address and how does that impact the deposit system? That's one of the areas that they're still kind of trying to figure out in terms of, and we'd love to work with them to try and understand that kind of situation, because the deposit structure will vary building to building and whether there's infrastructure required or not infrastructure requirements. So there's still a to-do on that one. We need to do a lot more understanding and working with developers to better understand that situation. The utilities were also interested in terms of EV charging. They didn't know where it was getting installed, and that was something that they wanted to do. It wasn't necessarily going to be reflective of this project, which is focusing mainly on new buildings and not existing buildings, but it is something that they were very interested in. And when they wanted to know when would it mean to electricity use and when will the charging occur and how does that going to get managed, and how can we future-proof for vehicle to grid readiness? So these were some of the kind of main concerns that we tried to bring into the EV costing study as best we could. Are there any questions from people just before we go on to this? We will dig into this more after Brendan's presentation, but I just wanted to kind of ask if there's any kind of clarification questions on this. Anyone? No? All right, we will carry on. So as part of all of this work, who funded the project? It was funded by the Atmospheric Fund. And as part of the EV costing study, what we were really trying to understand is how does the cost of charging infrastructure at the time of construction And how does that compare to the retrofitting post-construction? What is the pre and post construction cost associated with, and how do they compare with each other? Oh, I'll send the study is available. It was linked in the invitation to it, but I'm also going to throw it into the chat as soon as Brendan starts his presentation. I will throw the links for where you can access those things into the chat. And as part of the EV costing study, when we did get funding from the Atmospheric Fund to do AES Engineering, we always knew we wanted to work with AES Engineering because they have done a fair amount of this work in British Columbia. And we really wanted to understand and benefit from all of the work BC has done on EV uptake and EV requirements in new buildings in particular. I do have to say, British Columbia just recently came out with an incentive for EV charging in existing buildings, which made me very jealous because we don't have anything here for existing buildings, and it's a huge challenge, but it is something that we can learn a lot from BC on this one. And then they also wanted to kind of bring into the we wanted to understand from EV sharing, which we know had huge opportunities for better utilizing the grid and the electrical infrastructure in buildings, what would be the appropriate course? And Brendan will go into a bit about the methodology that was used and the data that informed the EV sharing across the GTHA area. And then also we just wanted to understand there were different kind of circumstances and rules in terms of the EV and utilities and charging taking place in Ontario. How would that impact how would that affect the EV costing here as well? And then there was a time lag between when the study was undertaken in BC and when we're doing it here that helped to update the costs as well. So those were some of the ideas behind the EV costing study and the rationale. And I wanted to turn it over to Brendan McEwen from AES Engineering. Brendan has been instrumental in advancing electric vehicle understanding, pros and cons all through the BC environment as well. And through his work at the City of Richmond, which set up the first EV charging requirements in all of North America. And then once he moved from the City of Richmond, he joined AES Engineering and has been leading their electric vehicle efforts and research as well. And we were really, really pleased to be able to have as part of the team on the Ontario EV costing study. So I'm going to turn it over to you, Brendan, to take us through the results of the take us through the results of the study, and then I will put the links to the reports where the reports can be accessed in the chat for everybody. Okay,
thanks so much, Gabby. Appreciate the chance to speak with everyone on the webinar here today. I'm Brendan McEwen, Director of Electric Mobility, Low Carbon Strategies at AES, and manage this project, and then have been, as Gabby alluded to, really active in I guess implementing the first 100% EV ready requirements, as well as consulting to other local governments and the federal governments and different folks down in the States as well on establishing these sorts of requirements in other jurisdictions. So we were really happy to partner with the Clean Air Partnership on this project. And I just want to acknowledge, I think we have Trevor from AES also on the line. So Trevor is an electrical designer who did a lot of work on the design and costing of this project. And we partnered with folks at Mulvey Banani, which is a great electrical engineering firm with a lot of presence in the greater Toronto area and more broadly. And we worked with them on a number of projects, including this one where they provided some peer review. So what I want to chat about today is firstly, providing some pertinent background information. So I'm going to do a really quick overview of EV trends and context. Just re-emphasize Gabby's point about the importance of access to home charging, say what we mean by EV ready parking, and also say a little bit about EV energy management systems, which, as Gabby alluded to, are critical to enabling high levels of future-proofed EV ready parking in both new developments and also existing buildings. And then I'll share in the second half the results of our EV ready residential parking costing study. So just speaking to the different building archetypes that we looked at and the range of design scenarios and the results there. So folks who've been on previous presentations we did on this in July and previously, some of this might be review, so apologies about that, but hopefully it's all useful material for most of the people on the call. So in terms of trends and context, firstly, just wanted to basically try to emphasize that EVs are the future, and in addition to the climate and air quality benefits that they entail, just due to the progress in the technology and economics, they are going to be essentially becoming dominant in the auto market in the non-distant future. So this is work that was done by the International Council on Clean Transportation. You find pretty much any other analyst looking in this space telling a pretty similar story, which is that pure battery electric plug-in EVs at long ranges, due to the declining cost in batteries, are going to become basically the same and then subsequently lower cost than conventional gas vehicles in terms of their first upfront costs by about the mid 2020s without any incentives. They're much already and will continue to be much lower cost to operate. It's probably the equivalent of 20 or 25 cents per liter of gasoline when you're driving an EV, much lower cost to maintain, and the vehicles last a lot longer. So once you hit this point where the first costs are also equivalent, it's hard to imagine why people are going to want to keep adopting EVs, and we see this transition happening very quickly. Now, plug-in hybrid electric vehicles, this top pink line, might play a role into the future, and there's definitely good models out there, but you don't see the same kind of cost decline dynamics as you do with pure battery electric vehicles, because they have two drivetrains running in parallel, both your internal combustion engine as well as your a small battery pack. And so you don't have that kind of price decline that comes with reducing battery costs. But again, the story this is telling is that EVs are already economically competitive on a life cycle basis, and they're going to be winning out on first cost too in North America, certainly within the next decade. Policy is also definitely driving EV adoption around the world. Canada's no exception. And this summer, the federal government announced that it's going to be adopting requirements that all passenger vehicle sales be zero emissions, which is going to practically mean they're all going to be plug-in electric vehicles by 2035. And just to, I guess, try to allay any sort of concern about the life cycle impacts of manufacturing EVs, this is again work from International Council on Clean Transportation that shows that, especially when you're charging on a relatively very clean grid like Ontario's is right now, but even if you're using sort of North America's average grid mix for the lifetime of these vehicles that you see in this bar right here, EVs are going to be much lower emissions over the life cycle of those vehicles than internal combustion engine vehicles in that first bar here. They have somewhat greater right now manufacturing impacts due to the need to produce those batteries, but it's dwarfed by those operating impacts. And one thing that's not shown here is as we have increasing electrification used in mining, in manufacturing, and in other parts of the life cycle processes that result in emissions, you can reduce the emissions that are both part of the vehicle's manufacturing, producing all that steel and aluminum and plastics and other components that go into vehicles, as well as certainly reducing the emissions intensity of the batteries. So that's very quick overview of trends in the EV space and why it's worthwhile supporting EVs. I want to talk about the need to support access to home charging. So the charging pyramid represents where vehicles tend to charge, and at-home charging is definitely the most critical factor to enable a household to choose an EV as their next vehicle. Workplace charging is also important, and you also need a network of on-the-go infrastructure, either at kind of commonly visited locations like grocery stores or other spots where people might stop for an hour or two or three, as well as very fast charging connecting metro areas. But right now in Canada, about 75% of all the charging that takes place is at home. Across North America, it's even higher. And the greatest barrier moving forward to EV adoption is ensuring that people have a convenient place to charge, and the most convenient spot is going to be home. So whenever we're building residential parking in particular, it's important to future-proof it going forward for EV charging infrastructure. It's usually relatively straightforward in, let's say, a single family home. If you have on-site parking, like a garage or a parking pad, usually fairly straightforward to get a good quality access to home charging, although not always. In multifamily buildings, it's usually very costly and complicated to retrofit those buildings properly to provide scalable access to EV charging. So the way we provide EV charging in most multifamily buildings right now is providing a couple of charging stations at a time, usually located in visitor parking or some other commonly accessible parking space. And then the idea is that the residents of that building are going to use that. It is typically quite expensive to implement that. You're talking about maybe $7,000 or $8,000 per parking space, per charging station, to renovate that charging infrastructure in. Now, as Gabby alluded to, we do have the EV Ready rebate program in BC right now, providing existing buildings with up to $80,000 per building to do a comprehensive EV Ready retrofit, $600 a parking space. And at those costs, that can provide like basically about half the cost of doing these comprehensive retrofits to make all the parking in those buildings EV ready. But it's still quite a challenge to get those existing condominiums and rental buildings to think comprehensively and do those sorts of comprehensive upgrades to their facilities to provide access to EV charging for all the residents in those buildings. It's something that we're starting to innovate, and AES is doing a lot of these projects as well as others out west here. But the bottom line is just so much easier and more cost effective to future-proof these buildings as part of new construction, rather than trying to coordinate with condominiums or with rental building owners what's going to be the successful retrofit strategy to get that infrastructure in. So going forward, we want to have multifamily buildings especially, but really all residential buildings with on-site parking future-proofed to have access to EV charging.
Brendan, if I could just interrupt for 1 second, just to kind of clarify, I missed a question I missed in the chat. But when you're doing your methodology for kind of comparing in terms of internal combustion engines to EVs, what kind of methodology do you use? Do you kind of use it based on like a kilowatt, or do you base it on how far you get on and what kind of fuel efficiency you assume for the internal combustion engine vehicle in terms of comparing the efficiency and reductions that you would get with electric vehicles?
I guess this question is with regards to my comment that the operating cost of an electric vehicle is the equivalent of about 20 or 25 cents per liter gasoline. And what we do is basically see how far a vehicle can go on, or basically how much gasoline or diesel it takes to get an internal combustion vehicle a certain distance, like let's say 100 kilometers, and how much electricity it takes to get an electric vehicle that same distance, 100 kilometers. And then translate that into, well, how much is it going to cost for that gasoline or diesel, or rather how much it's going to cost for that electricity. So we do those calculations. It really depends on the electrical rate and when you're charging. But let's say if you're kind of a residential rate structure in Ontario, I think it's quite reasonable to say it'll cost 20 or 25 cents a liter equivalent of gasoline when you look at comparable types of vehicles. So if you're looking at like a Model 3, a comparable gasoline vehicle, if you're looking at a Ford F-150, the Ford F-150 electric, then you'd look at the same gasoline version.
Perfect, thank you.
Sure.
Actually, one of the things that might help, actually, because I was just thinking that might actually help for the sustainable fleets effort that we're doing as well, to kind of have a consistent methodology used in the value proposition for comparing internal combustion to electric vehicles. So I'll probably follow up with you another time on that one.
Yeah, we do a lot of that kind of work for fleets for sure.
Perfect, thank you.
Sure. So EV energy management systems are really important technology to have a bit of an understanding of when we think about how we're going to provide charging infrastructure at scale in residential buildings, as well as different contexts too, like workplace parking or certainly fleets as well. So basically, EV energy management systems refer to charging stations. It's usually the controls done at the charging station level that have a bit of intelligence and can monitor and control EV loads. So on the diagram here, you can imagine if just one of the vehicles is here and plugged in, it could take the full capacity of this branch circuit from an electrical panel. And if that branch circuit's capacity is 40 amps, it can take that full 40 amps and charge relatively quickly. When multiple other vehicles plug in, the chargers communicate with the vehicles, figure out how much power the vehicle is demanding, and then they balance and throttle down between them so that they don't exceed the capacity of this branch circuit and blow the breaker. And they communicate usually via cellular or wireless, and then there's other sorts of technologies too, Ethernet cable and others. So that's the basic idea, again, is that they are charging systems that have some intelligence and can then monitor and control those EV loads and essentially reduce the amount of electrical infrastructure that you need to put in to provide charging for those vehicles. There's a variety of different sorts of electrical configurations for how the wiring might be configured that provide that you can use different sort of types of EV energy management systems with them. So in the top left is a common sort of form of electrical infrastructure configurations that you would see in multifamily buildings that are being constructed to provide a decent, like a good quality of service for the residents, but in a cost-effective ways for a developer or in a retrofit context as well. And that's circuit sharing. So you're doing sharing multiple charging stations across a branch circuit coming off of this panel. And there might be multiple, though it's not shown here, multiple branch circuits coming off of that panel, each supporting, in this case, 4 share on that 40 amp circuit, and you can provide different levels of sharing. There's also panel sharing you see here in the top right, where you kind of overload the capacity of the electrical panel. So if it's a 200 amp panel, you might have 400 amps worth of branch circuits off of that, but an EV energy management system there to control it so that you don't exceed the capacity of that panel. There's systems like feeder sharing, where you're ensuring that, let's say, a home's electrical panel isn't being overloaded, and whenever there's capacity, providing that power to the EV charging station. And then here, bottom right, is service monitoring. So service monitoring is where you're actually monitoring the main electrical service into a building, like let's say in this case, a larger multifamily building. And you've got a current transformer, so this little monitoring device that's on that main service. And it's ensuring that the building isn't approaching the capacity of that service and of the building's main transformer or of a major feeder's service or size. And as long as there's capacity there, it's communicating to the charging station saying, yep, continue charging, you're okay. And if there isn't capacity, it communicates to them and says, throttle down or turn off. There's not capacity right now for you to charge. And that ensures that you're not going to exceed, let's say, a limit like 80% of that building service. Now, one thing that's interesting is in new construction, the electrical code is inherently conservative. So for so many of these multifamily buildings, the very highest loading over the course of a whole year that that building's main transformer and service might have could only be like 30% of its actual nominal capacity. So there's all this additional capacity that you're able to provide EV charging for within the existing capacity of those buildings as they would be designed without any EV charging infrastructure. So hopefully that makes a bit of sense. We can return to that a little later on in my presentation. And I'll just also note that there's, I noted one of these previously on the feeder sharing, but basically these are examples of systems for single family homes and townhome applications in particular, where either, again, you'd be monitoring the capacity of the main panel and providing charging for the EV charger whenever the capacity of the panel isn't being approached. Or you could just have two major loads. Let's say instead of a hot tub, this would be your EV charging. And so if your stove or your dryer's on, your EV won't be charging. But whenever those things aren't in use, your EV can be charging. That'll provide a perfectly adequate quality of service. So these are some examples of different sorts of EV energy management configurations that can be used. So what do we mean by EV ready when we use these in the context of local government requirements or programs that are providing EV charging infrastructure in buildings? EV ready infrastructure means all the electrical infrastructure necessary to provide charging to an EV up to a junction box or a receptacle, so what's called an energized outlet. And then you would install charging stations over time at a future date as households adopt EVs. So in a multifamily building, everyone would get that energized outlet beside their parking space. And as I, adopt an EV 2 or 3 years after I've moved in, I get a charging station that's going to be compatible with the building's EV energy management system, if there is one. And for almost all designs, there would be, although certainly possible to do this without the need of that. It just might require more electrical capacity in the building. So you'll get the right kind of charging station, have it hardwired in or plugged in, and you're able to charge your vehicle. So that's what we mean by EV ready, the presence of that electrical outlet. And just to be clear, energized outlet, usually a junction box, can also be a receptacle. And as we noted at the front, there's been a lot of activity by Canadian municipalities to establish EV ready requirements for new construction. So Richmond, I think we developed this in 2017, Vancouver followed suit shortly thereafter. And now I think it's 17 communities in BC have 100% EV ready requirements. Toronto, it's great that there's, oops, I should have changed that to 100% requirements. Apologies, Lisa and Deborah and others at Toronto. Tier 2 of the Toronto Green Standard is 100% EV ready requirements. And in the future, it's going to be 100% as committed to in their EV strategy. We've seen Laval have 50% EV ready. So there's a lot of action. I'm speaking with a number of other major municipalities across the country. So I think a year from now, this map is going to look much more filled out, which is fantastic to see, because again, this is really critical to enabling EV adoption. And I'll just say a little bit about charging performance requirements. When you're designing for EV energy management, you want to ensure that people are going to have enough power to charge. So how much power you need to charge is largely, although not solely, a product of how far households tend to drive in a given area. So we got data from the Transportation for Tomorrow survey that looked across the GTHA of how far vehicles tend to drive in these different locations. And you see that where most of the multifamily development that's occurring in the region occurs, households tend not to travel more than, let's say, about 45 kilometers per day. So we've got a model that we've developed that does a series of calculations on data to determine what are sort of the appropriate maximum amounts of power sharing that you can provide, or another way of phrasing it is, what are the appropriate minimum charging performance requirements? For many places, it's perfectly reasonable to do 4 share across 40 amp circuits. It wouldn't provide any valuable sort of future proofing whatsoever for those buildings to do 40 share across 40 amp circuits. It would be too much and people wouldn't have a good quality of charge. So we want to determine what are those types of levels. So our model considers how far vehicles are driving each day. Also what the typical efficiency of that EV fleet that we would expect 20 years in the future when everyone's driving EVs will be. So are they all driving electric Hummers, or is everyone driving the Model 3, like the most efficient vehicle ever built? What's the average temperatures in the region? And then what are the arrival and departure times? We make what I would term conservative assumptions for all these different factors. And then the model optimizes to allow for as much sharing as appropriate, provided that you're going to have at least enough electricity for households to do their next day of driving 99% of time, or at least 99% of the time, and a full charge, like a completely filled up battery the next day, greater than 90% of the time. Again, I think our assumptions are conservative and people will have a better quality experience than that. So there are certain cases where that household at that, less than 1% of the time would need to visit a public charger, or this is assuming all the charging takes place at home. And in reality, hopefully some of those households, in addition to having access to home charging, are also going to be having access to workplace charging and taking advantage of cheap solar in the middle of the day. So the picture is going to be even better than this. There's going to be a much greater percentage of the time when households aren't going to need to get access to any other charging, but this is kind of what the model's optimizing for. And he compared that with what used to be in the Toronto Green Standard version 3. They adopted version 4 this summer when we started the project. The scenarios were developed around version 3. And that says has to be capable of supplying 16 kilowatt hours average per EVC over an 8-hour period. That equates to 3 share on 40 amp circuits. So what we found, given you see where people tend to be driving, there's a lot of areas where you can't actually get away with greater amounts of sharing. So for many of the jurisdictions, I'd say Toronto for sure, probably Mississauga, Hamilton, others, you're looking at 45 kilometers per vehicle or less a day. And this value, this sort of column here is appropriate. For those that are driving in communities further, you might want to consider having higher performance requirements. And as we'll get to shortly, that would cost more for new development. You could also consider just matching what folks in, let's say, Toronto or Hamilton are doing, because hopefully in the future, people will also have access to workplace or public charging infrastructure. And, if it was a choice between doing no future proofing in those types of communities versus providing at least this amount and providing perfectly adequate charging for the adoption, let's say over the next 5 or 10 years, and then needing to build out more workplace charging and having that augment people's home charging, I think that'll still be a win even when you get into these communities that are at these higher levels. But if you're in a more sort of suburban, exurban community where people are driving further, you may want to consider, well, can we do, let's say, the charging performance requirement for a kind of typical vehicle duty cycle of 55 kilometers a day. I'll turn now to our costing study. So the process basically is that we have a series of building archetypes, and we first do electrical load calculations to see what a building without any EV charging infrastructure, so the baseline scenario, what it would cost per parking space, or sorry, how much electrical load will that building in that baseline need to provide. So how large is your electrical system going to be, and what's the electrical design for it, and what is your load calculation? And then also look at a series of scenarios for your EV charging configurations. We then have on these different EV charging configurations, we do single line diagrams and layout drawings. So electrical single line diagram showing just electrically what's the infrastructure that's going to be in place, then showing the actual wiring runs in the building through these layout drawings. And then based on those single lines and the layout drawings, we do cost estimates for our baseline, and then the incremental cost to upgrade that infrastructure for your different EV charging scenarios, which I'll speak to momentarily. And finally, report out on what those costs are. So we looked at 4 different building archetypes that are common to the GTHA: high-rise, mid-rise, townhouse, and single family. And you see the number of parking stalls over here. We only looked at future-proofing the residential parking, so not the visitor parking. This is just to provide households with EV charging where they park their vehicles every night. And then I'll just share a couple of examples of the designs we did for different scenarios. So this would be 4 share on 40 amp branch circuits with service monitoring for our mid-rise scenario. That's the single line diagram that shows down here at the bottom. Apologies to folks, this is a bit of an eye chart. but you can see the outlets here at the bottom, 4 share on each branch circuit coming off of panels. And these are the layout drawings for that particular scenario. This is townhome for a 2 share on 40 amp branch circuits with a load switching device. So we've got a circuit that's coming out to your garage and the parking pad outside that has these 2 outlets on it. And then it also shares that circuit with the dryer. So when the dryer's on, the EV charging won't be, but all other times the EV charging can be. You can see here, this is the plan view of where all the infrastructure, where the parking spaces are. Single car garage and then an outside parking pad as well. And there's junction boxes sharing a circuit at each. In reality, like a household, when they use this, they could either implement just 1 charging station and sort of switch their vehicles between them. Or if they wanted, they could have 2 share and need to have charging stations that can communicate with each other. They're both quite viable options. So again, the costing for each of these electrical components here, we look at what the cost to upgrade from the baseline building to that particular design's electrical infrastructure would be. And we say, all right, well, that's the cost to upgrade, our distribution boards, our transformer, EV distribution boards, and other components. And we have the total cost here, and then a cost per parking space, residential parking space in the building. And I'd also just note that we included a rough estimate of what it would cost to upgrade in kind of an incremental fashion the parking spaces. So this is admittedly a pretty coarse methodology just to give an indication of what it's going to cost per parking space to provide incremental upgrades, adding a few charging stations at a time. In reality, it's often possible to retrofit existing multifamily buildings in a comprehensive way, more cost effectively, but we also should not depend on multifamily buildings just to do sensible retrofits after the fact. It's always going to be easier to put in that 100% infrastructure up front rather than trying to retrofit it in. So we made an estimate here of what that kind of incremental cost of upgrading the infrastructure is going to be.
And Brendan, just to kind of help people kind of visualize how this what 100% EV ready looks like in terms of where the plug actually ends up being. That just means that there's different wiring within there's allocation for electricity within the fuse box, that the conduit is all going to the actual place where the vehicle will be parked, and that there is an energized outlet that a charger can then, whenever they decide to install their charger, just plugs into. Is that correct?
That's right. Yeah. So you see each of these townhouse units, this is a plan view of the whole development. It shows the garages. At each parking spot, there's an outlet where you can install a charging station in the future. So the household, when they get an EV, they would go install an outlet there or install that EV. They don't need to do any upstream electrical works in order to implement that. The outlet's right there. So all they need to do is plug in or hardwire that charging station into the wall there, and they'll be good to go. Now, there are some circumstances where they would need to choose the right charging station and have it configured to do EV energy management. You see this too in the multifamily building. Every one of these parking spaces has an adjacent outlet where you can install a charging station in the future, and it's got the right kind of infrastructure to work. You see some sort of ways municipalities define this where they say, oh, we'll just put in conduit and that'll make it easy to install this in the future. It does not make it easy at all. The cost is in that upstream electrical infrastructure, and it makes it very complicated just to have the conduit. It basically does nothing to future-proof the buildings. What you want is to have the wire in the wall, and you want that wire to be supplied in all your electrical systems sized appropriately to provide EV charging using whatever sort of energy management system it's designed to use. So yeah, hopefully that all helps.
And Heather, if that's any question, but yes, there is an outlet that's in the wall and it's near the parking spot, so that the only thing that the driver has to do when they install the charging thing is connect that charger to the energized outlet.
Yeah.
Thank you.
So you're welcome. We looked at a variety of different design scenarios for each of these archetypes. So we have the description of the electrical configurations here in this second column. The first two ones we implemented were compliant with Toronto Green Standard version 3. We designed these scenarios, I guess, early this year. And so version 3 was what's applicable, and was maybe what other local governments have been thinking of. Well, should we replicate that? So what version 3 required is 20% of parking spaces be EV ready. And we looked at two scenarios that would be compliant. One would be dedicated circuits to each stall, so not designing for any kind of load sharing using energy management. And one would be allowing 3 share on 40 amps, as was allowed for under the Toronto Green Standard version 3. We then have 5 scenarios, C3 through C7, that provide 100% EV ready parking. So we've got one that's dedicated 40 amp circuits to each stall, so there's no load sharing between those vehicles. Each one is just the full capacity of that circuit to each parking space. Then we have one that's 3 share on 40. We've got one that's 4 share on 40, reflecting the revised minimum performance requirements we'd recommend are appropriate for a lot of the areas in the GTHA where there's multifamily development occurring. And then another one that our performance requirement suggested is appropriate, where you're putting 40 amp EV chargers on 10 share on an 80 amp branch circuit. And basically, as you go up in amperage and you provide more power, you can kind of get away with charging more vehicles per unit of power than you can at lesser charging, because it's like the law of large numbers. It's unlikely, or it's much less likely, that all 10 households are going to be there and need a lot of charge over the course of that night than, let's say, 4 households, 4 neighbors next to each other. So because of that, because some people might not have taken the car out that day, you can get away with proportionately more sharing and still provide everyone a really great quality of charge. And then we also looked at a scenario with 4 share on 40 amp that use service monitoring. So with that service monitoring, you're avoiding an upgrade to your service size and your transformer by using that service monitoring. Mid-rise, we had basically the same sorts of scenarios that were conducted as in the high-rise. And then in the townhouse, we did one that's a simple 2 share on 40 amp. So 2 parking spaces being served by one 40 amp circuit. And then we also had service monitoring, where you're monitoring the townhome's whole electrical service to this complex, where you maybe have one transformer serving multiple households, and each household within those townhomes would kind of have stipulations that they need to get EV chargers that are compatible with that service monitoring type of solution. And then we also did it with load switching, where you wouldn't need each household to have that sort of compatible charging infrastructure or compatible charging stations with that energy management. You would just basically have switching between your dryer and your EV load. What that basically allows you to do is not calculate your dryer loads in your electrical calculations, because your EVs are continuous loads, and you're just assuming the EV charging is always on for the purpose of an electrical calculation, but your EV load and your dryer is not going to be occurring at the same time. And then for single family homes, again, we had one where there's no EV energy management assumed, and then one where you're using load switching. So I'll share the results. We looked both at Toronto hydro area and electric territory as well. This being for a broader audience, I'm just showing the high-rise results for Electra. This is reported in cost per EV ready parking space, not total cost for the building, but cost per the EV ready parking space. And then we've got the different components of the cost broken out by what is associated with your metering, with your communication system, so your energy management sort of provisions, your EV panels and cabling, and then also like the feeders and increasing to transformer service. And in this high-rise case, for the 100% EV ready scenarios, the last one here, C7, where we've got 4 share using service monitoring, is in this case going to be the most cost-effective option. You're looking at a cost a little over $1,500 a parking space to implement that. So it's certainly not no cost. I will note this was done for 2021 costs. We did see significant escalation, as I'm sure many folks have heard about, significant inflation in construction costs as we're coming out of COVID. Hopefully that's temporary. We'll see all elements of construction costs have tended to increase. Electricals, no different. So this is more than we've looked at in other costing studies that we've done. Conversely, it's a very small percentage of the cost of providing on-site parking. So you think about providing structural parking in these multifamily spaces, probably each one of those parking spaces is maybe for your first floor, like 50 grand or more, probably more at this point. And then it goes up for each layer, you're going down and needing to do more excavation. It's not uncommon for it to cost like 80 grand or more per parking space. So it's relatively small potatoes in the grand scheme of the cost of construction as a whole, certainly as the cost of providing parking. And if we're going to be providing parking in new developments, and we should probably be providing less because we want to encourage people, like not subsidize the automobile use and provide developers options to basically build less parking in their developments. That's going to result in overall less vehicle ownership as well as much lower embodied emissions in buildings. But if we're going to be providing that parking, we really need to provide those households with the options to adopt EVs. And there's ways to do it with relatively conservative assumptions that are just a little over $1,500 a parking space to do so. For the mid-rise, the cost was $1,500 a parking space for this 10 share on 80 amp sort of scenario. So that would be the lowest cost way of complying. And then these costs aren't per parking space, they're per garage or basically per household. And when you put in all the energy management systems with, I'd say, fairly conservative costs for what it's going to cost to procure and install that, I think there's a lot of room for these sorts of systems to decline in cost into the future. You're looking in the townhouse scenario at an incremental cost of, in the low cost scenario, this would be the load switching with the load miser, about $2,000 per garage, or basically per housing unit, and single family a little over $1,500 per garage. And again, you can see here in almost all these scenarios, it's designing for in, let's say, mid-rise and high-rise. Certainly when you're doing load sharing across circuits, it's going to be a lot more cost effective than doing dedicated circuits to each parking stall, and that's going to be true pretty much all the time, no matter where you're building. You want to design for that kind of load sharing approach. For these townhome and single family archetypes, if you weren't doing any kind of energy management, we found in these ones a fairly substantial cost. Most of this is because we were upgrading the panels and then also the cabling to be 200 amp panels instead of 100. So we were assuming kind of a baseline of 100 amp panels. That's a fairly conservative assumption, especially as we move forward. We're going to need to electrify not just vehicles, but of course buildings as well. For new construction especially, it's going to make a lot of sense to go towards all electric buildings that are providing space heating through heat pumps and also providing cooling through those. And when you count the savings in mechanical systems for not having separate gas and electrical, the gas as well as air conditioning, and then also the savings you can have in plumbing, going to all electric buildings is going to make good sense, but you're probably going to be upgrading your electrical systems to do that, in which case it's much more likely you're going to be able to fit your EV charging onto the size of those panels. But these ones, we were conservatively assuming 100 amp panels, and in these particular scenarios needed some kind of energy management system to put that in. I will say, if you do, and maybe it's something we should have looked at, I'm happy to discuss this more. If we were to assume like a 200 amp panel is a baseline, it's very cost effective just to do like a dedicated circuit from those panels to those vehicles, particularly in single family subdivisions, and then also often in the townhouses as well. And you may not need any kind of energy management, and you're going to have quite modest costs. But this is showing, even if you are assuming that kind of baseline of 100 amp panels, there's reasonably cost effective ways of doing this that I think households are going to be really well served by having required from the outset to be implemented. And the final point I'll note before wrapping up is that there is real value in doing this in new construction versus as a series of incremental retrofits. This shows an example for the high rise of what the cost for 100% new would be versus our kind of rough calculation of what it would cost to provide that kind of charging infrastructure on an incremental basis, as is the way that we're usually seeing EV charging implemented in multifamily buildings. You're going to save a lot of money and sort of impose a lot less costs and heartache and complications on those building occupants if you get this right from the outset. So just to wrap up, conclusions, you can achieve 100% EV ready in basically all these archetypes for 1,500 to maybe 2,000 for the townhome with conservative assumptions. When you're designing for use of EV energy management, so having electricians and electrical designers who are knowledgeable in this is going to be an important part of implementing it, but it's stuff that's absolutely allowed in the electrical code, and we're having a lot of success out west implementing in most new construction. And so is, I think, quite doable in the obvious direction for the industry to go. And it's going to be a lot, just to sort of drive the point home, much better to do this in that new construction than on a retrofit basis. So thanks so much. Hopefully that's all useful. And I apologize if I was a little bit more long-winded than we were hoping, but hopefully we've got some time for some questions.
No worries, Brendan. We've got time for discussions, and we have some questions already in the chat. But I wanted to really open up the floor. There's a number of different ways you can ask your question, whichever one suits you better. You can just unmute and ask your question. You can raise your hand, and then I'll call on you. You can put your question in the chat. So there's many different mechanisms for asking your questions, and we don't want you to be shy. Like, just ask as many questions as you can. One of the things we're trying to understand is what are still the questions that people have going through their brain that we need to be able to kind of make sure to address. And we're looking to kind of say, like, okay, maybe we need to develop an FAQ that would kind of accompany the report and everything like that. So we really wanted to kind of understand what questions are still milling around in your head. Brendan, just one question to clarification. The costs that are associated with it include all the labor costs of running the wires and everything like that. Is that correct? It includes the electricity allocation kind of considerations, the labor costs associated with it, the materials that it includes as well. It just doesn't include the charger, because that's up to the driver whenever they decide to install the charger. Is that correct?
That's correct.
Perfect. Thanks. And if you can just raise again the timing for when these costs were taken into consideration, because it was during the COVID time period. I think it was February 2021 what you were using the numbers, and copper prices being what they are, and the numbers that we found here in Ontario, because they were taken during this time period of COVID and supply chain disruption and material price changes taking place. I mean, let's say, for example, the material costs were higher in the Ontario study because of those supply chain and price differentials than when BC was undertaking their costing study. Is that correct?
Yeah, that's right. So these numbers, we got the RS means data from Q1 2021. So RS means is this big data set of what it's anticipated to cost to construct stuff, and we use that to sort of Greater Toronto values for Q1 2021, which is definitely a higher cost of construction. There was like a lot of construction cost inflation. Basically, at that point, it's kind of situation is fluid. There's still a lot of that, and things are more expensive than they were 2 years ago. But I think it's getting it reflects that, and we'll see what the future holds on those types of dynamics. Yeah, I'd hate to speculate on it.
Yeah, me too. I don't want to even try speculating on that one.
Yeah.
Gil, just take it over. Just unmute yourself and ask your question.
Yeah, sure. I missed a tiny bit of the presentation, excuse me, but Gabby mentioned in the beginning some takeaways for municipalities. So I'm wondering from you, Brendan, or from you, Gabby, what are the main takeaways, and what are the key actions that municipalities need to focus on in terms of this research?
Yeah, I mean, that's a great question, Gil, and apologies that I got into the weeds and then didn't take us back out. But basically, to my mind, you absolutely want to, as soon as possible, have on your work plans, exploring developing 100% EV ready requirements for new construction. The way communities out west have adopted these is having them be parking requirements. So municipalities typically either have a parking section of their zoning bylaw or a standalone parking bylaw. Either way, those bylaws will make a number of sort of stipulations around parking design. And communities out west have been quite confident they've got authority to, in those bylaws, include design with regards to EV ready future proofing. So this is one of the most important things that any jurisdiction's able to do to enable EV adoption in their communities. So we want municipalities to be thinking about how to adopt those types of requirements. I think it's going to take engagement with the development industry, which Clean Air Partnership is going to play a role in, as we understand it. And then also, just working with your planning group and your legal counsel and saying, yeah, how are we going to do this? And folks, please do feel free to reach out to me, and I can share sort of experience from out west on like how this was done. I think there are some useful sort of precedents, although of course, like jurisdictions in Ontario are going to have to feel comfortable doing this as well. Those are my thoughts. Gabby, sorry to jump in right there, but happy for you to share anything else, of course.
For sure. And there's actually one of the questions that did come onto it from Heather in the chat as well, which we'll get to that as well. But certainly from the perspective, municipalities have been wondering what's the mechanisms, and the two mechanisms that have that have been identified within municipalities for securing the EV requirements would be their site plan controls through the green standards through their site plan controls, and the bylaws through their parking requirements. There are a number of municipalities who are looking to address their minimum parking requirements as well because of the onus it puts onto it. There's some challenges, obviously, that a lot of municipalities are facing with regards to resistance from the community when it comes to parking requirements, in particular in the MURB sector, and what that means for parking on streets at present. So that's an issue that many municipalities are also looking to try to figure out how do they balance that. But those are the two mechanisms that are available to you. And I know that from the conversations that Brendan has been having with the City of Toronto as well, there was that raised the issue that zoning bylaws do not allow objects within the dimensions of the parking space, or else it's not considered like a legal parking space. But the chargers would be actually installed in those parking space allocations. So that would be another thing that needs to be addressed as well within parking requirements for municipalities, because it would require that the EV charger be in the designated spot of the parking spot. There's other mechanisms, but they're more costly to try and address. And I'll leave it to Brendan to kind of fill that kind of in terms of the location for where the chargers actually go.
Yeah, but I mean, Gil, to your question, I think it's got great bang for buck for municipalities to adopt EV ready requirements for new construction and require 100%. Just to that last point about where chargers go, these things, most models have quite modest dimensions. I think it makes all the sense in the world just to, in structural parking, have them be wall mounted and not change the dimensions of the parking space. And so that's something is kind of like an implementation detail can be worked out.
Can I don't.
Go ahead,
Yeah,
Heather.
go for it, Heather.
Sorry, Brendan, I didn't mean to cut you off. The dimensions of a parking space actually have a vertical clearance as well. So technically speaking, what we've been seeing in Toronto is that applicants need to get a minor variance for every single parking space that has an EV charging equipment in it. It's 2.1 meters clear from the ground. So Michael Hain and I and a few others were leading the zoning bylaw review right now to try and permit EV equipment to be installed at the front, if you want to call it the front, where the wall is, if there is a wall present. So we're trying to do that now. It's going to Planning and Housing Committee at the end of this month and Council in December. So we'll see if that gets passed. But I guess I was curious if you have seen other municipalities who have updated or made permissions within their zoning bylaw requirements to allow EV equipment. I know it's small. It's a technicality within the zoning bylaw though, which is annoying.
I haven't come across another local government that is running into this issue. If it's like I totally think it's like a technicality that if municipalities need to clear that out, then yeah, we should do that. I think it would be a mistake to try to change the dimensions of parking spaces to allow for this. Like the bottom line is we're either going to have EV charging infrastructure ubiquitous at all parking, or we're all toast, like this is a transition that's going to need to happen. And so we need to enable it. To my mind, it would be a shame if we then said, okay, well, every parking space needs to be an extra 10 inches long, because that'll just have implications on, when you look at that in aggregate, parking area dimensions, the footprint of buildings that's required to develop. I'm sure in a number of cases it wouldn't be an issue, but it can, in some cases, lead to like just basically more cost of construction and more land area or building area needing to be devoted to parking, which I think would be unfortunate.
Agreed.
Yeah.
Sorry, what I should clarify is that we're not changing the size of the parking stall to 656, but we're giving the applicant permission to install EV equipment within the parking space.
Yeah,
if that makes sense.
Yeah, and that makes perfect sense. And sorry if I was implying otherwise.
Good.
Yeah.
No. I wanted to make sure that the logic was there. So that's good. Glad to hear. Thank you.
And thus far, Heather, most municipalities have been looking to their green standard authorities as one of the mechanisms for it. So far, no Ontario municipality has changed their parking requirements to require EV ready requirements. That doesn't mean that they wouldn't be using it as a longer term strategy for that. Let's just say, for example, a municipality that doesn't have a green standards may decide to just use their parking requirements rather than setting up a green standard.
Yeah. And you all probably have a much better sense of how efficiently the green standard works. When we were doing this in Richmond and talking with our planning department, it was felt like, well, if we're going to require the same thing for each building, let's just put it in our parking requirements, seeing as we're confident that we're able to do that, because it'll be administratively simpler. And it's like sometimes we have council policies that ask for what we want to see green, but it's a little bit more negotiated. So I guess it just depends on the culture of the green standard and when it if it's sort of negotiable versus like just an absolute requirement in development. If it's the latter, it's probably all the same. If it is something that like it is a little difficult for planning departments to need to put together a covenant that the development is going to adhere to that green standard for every project, and there's additional sort of paperwork, I think it's worthwhile exploring. Can you just have that as sort of the default requirement in the community?
Yeah. And there was a question with regards to the Ontario Building Code, and is because that's another kind of avenue. Is it better to focus in on getting EV ready requirements put back into the Ontario Building Code rather than focusing in on the municipal role with regards to green standards or zoning and parking requirements? And certainly there would be some, I think, momentum towards moving on the Ontario Building Code. I just be considering the time frame for how changes get put into the building code. I think it'd be a real shame and a lost opportunity for municipalities not to advance the authorities that are available to them to ensure EV readiness and uptake within their communities. So it's not like it's either or, it's kind of probably, the municipality has these opportunities if they really want to making sure that their municipality is not falling behind in terms of EV readiness and uptake. And from the consideration of how much it costs, particular the MERB sector to retrofit this post-construction, that's where it makes the most sense for municipalities to advance 100% EV ready requirements. But it still makes sense within even this in the low rise Part 9 buildings in particular, because you can see the price differential for what it is post retrofit versus retrofit versus at time of construction. So it's just, it goes to show you, like, I think that, and in addition, I think one of the things that we also bring into it, there's definitely going to be a transformation in our transportation system, and a lot of internal combustion engines moving outside of the market share, and EVs increasing in their market share. And that's going to be all across Ontario. But in particular, the high amount of growth taking place in Southern Ontario, waiting for the building code to address EV readiness, I think would be a huge lost opportunity and a lot of increased cost on the part of residents to enable EV charging within their for at-home charging. So that's one of the reasons why I think it's really important, and why a lot of municipalities are really looking to their opportunities to address 100% EV ready and readiness within their community.
Yeah, I'd just echo that. I think cities need to lead. I hope provinces will start surprising me, but I really think that there's great value in progressive cities taking the lead on this kind of stuff and implementing effective types of policies. And it feels really good doing that kind of leadership from my experience. So I'd encourage you to strongly consider it for sure.
And some of the things we've heard thus far from the municipalities in terms of the consultations on what's the pros and cons associated with using green standards. One of the main things is like the green standards in particular, if you have a green standard that's a menu approach, that you give the developer the opportunity to identify which metrics they are going to incorporate, that might be a weakness in the part of their 100% EV ready, that the developer may or may not choose that as a metric that they're going to incorporate into their building. In which case, if you do have a menu style approach, you probably really want to dig into either making that a mandatory metric still within your green standard, but making it a mandatory metric, versus, or you could go into your parking requirements and use the bylaw authorities to make it a requirement, and then not complicate your green standards if you wanted to, even though I don't think it really complicates, because there's lots of metrics within your green standard that are kind of mandatory minimum standards that you pick from, and then the aspirational targets that are associated with green standards as well. So there's different pros and cons, and all of them can work. And if you have a green standard in place, it makes sense that that's probably where you would explore, and then try and work with your parking folks to try and see the pros and cons from their perspective. But if you do not have a green standard in place, and you don't necessarily, and the municipality hasn't made a commitment to developing a green standard, that's where we've seen some of the municipalities really digging into their parking authorities to be able to secure the 100% EV readiness. And in some jurisdictions, they're also considering how can that work with, how can they use the minimum parking requirements as a mechanism to address some of the kind of cost concerns that developers may have with regards to 100% EV charging, even though in the whole scheme of things, those charges, especially when using EV sharing and load management, are very, very minimal in terms of the overall cost associated with parking for vehicles as a whole. So any other questions for folks that they'd like to dig into? We are looking to try and understand, and I know you haven't had a chance yet, and this is this might be the first time you've seen the results of the EV costing study and need more time, but I just wanted to kind of give you a heads up, or maybe even a warning, that we will be kind of coming back to you on a regular basis, just to better understand how far does the EV costing studies and the parking requirements guidelines provide you in terms of the conversations that you need to have within your municipality, and how can we help you work, we're here to help kind of engage with you on those conversations within your municipality. And we really want to try and understand all of the questions that come to the forefront on those conversations, so we can create a bit of an FAQ to help simplify these conversations on an ongoing basis and to build our collective knowledge as a whole on the 100% EV, on 100% EV readiness that we're trying to advance, particularly in the new build sector. Obviously, we know we have another huge challenge on our hands on the existing building front, which we will worry about, once we make progress on the new buildings. And if I could just add one more thing that I also think that's really important on this, advancing the new building and EV readiness of new buildings will help us significantly in addressing cost concerns on existing building retrofits. But we know that there is no better time to ensure EV readiness of the building than at the point of construction. And we really want to try and understand this also from the perspective of developers. Really want to understand what's the barriers and issues that you think that we need to kind of take into consideration on this. So please just reach out to us. Let us know any types of questions. Don't be shy to send me an email. And we will send out the PDF, the links to the reports, which are also in the chat here, and the links, and I'll send you also the link to Brendan's presentation as well. And please, really want to open up the thing. Anytime you have questions on this, just send me an email, and we are compiling all the questions that we get back from different stakeholders. And if there's some consultations that would be of value, thanks, Brendan. I appreciate that. Brendan just put another link in there. And if there is some consultations within your, any of the stakeholder groups, whether it be utilities, developers, or municipalities, really want to understand where we're here to kind of engage with you on those conversations to better understand things from each of the different stakeholders' perspectives. Are there any last questions that came to mind in terms of next steps? Okay, no? So Brendan, thank you so much. Thanks for all your fabulous work on the EV costing study and for the presentations as well that you've been providing. I really appreciate that. And also wanted to kind of thank you for all of the back and forth and helping to bring all of us up to speed on what's the leading efforts from municipalities. So one other question that came to it, reducing, yes, many urban municipalities are moving towards reducing or eliminating parking requirements in new residential developments due to affordability concerns and shifting mobility trends. Developers are being left with unsold parking spots after a MURB is completed. So out of curiosity, if you could just kind of, Paul, if you can just unmute just to describe that thing, because wouldn't the minimum requirements be approved? Like, wouldn't the minimum parking requirements be approved? Oh, if you can just explain that just a little bit more, just because wouldn't minimum parking requirements be approved before they're constructed? Or are you saying because of the minimum, the minimum parking requirements that municipalities have, there's an overbuilding of parking spots, which then adds to cost? Is that what you were saying?
That's exactly it. There's currently a trend, and it's been happening for the last 5 to 10 years. And a lot of it is just because of the price of a parking spot. We're seeing it kind of top out around $175,000 per stall to the cost of an end user. And that's not including an EV ready stall. That's just a regular stall. Seeing about an extra 10 grand on top of that. That's market price. And when developers are being left with all these unsold spots, that's obviously a concern. So we're really happy with what the city's doing. And I think someone from Michael Haynes' office was on the call. They're looking at getting rid of or modifying the parking minimums and moving to parking maximums. Because in the city of Toronto, there really is just, the demand is not there. There's so much money being put into transit infrastructure and bike lanes and all that. So I wouldn't want the EV stuff to move forward until the parking demand stuff is actually figured out. That's kind of one concern that developers always have is making spots EV ready that aren't even being sold. That's not helpful. So first, figuring out how much parking is actually required is the key here. And then the EV ready piece obviously fits in with tailoring demand to the EV demand of parking.
So Paul, firstly, I completely agree with you that it's very silly that we have requirements for parking in all these residences and that they're so high. You know, we basically ensure that we're going to have abundant housing for cars, but not for people. So it's just not right. I think one of the best books, and I really ought to start including a screenshot of it in my slides, but The High Cost of Free Parking by Donald Shoup is a wonderful book. So I absolutely endorse the idea of eliminating or at least reducing minimum parking requirements. I guess I should rephrase, I absolutely endorse the idea of eliminating minimum parking requirements, and then if you can't do that, at least reducing them. I question whether there is the need for the staging of the two policies you're suggesting. I don't know that cities need to get their parking minimums worked out. I think it should be also a priority and they should do it as soon as possible. But basically what this ensures that wherever there is residential parking, if that's implemented due to parking minimums, or if that's implemented due to just the market demanding that parking and developers feeling like they can sell it, that you're going to be able to provide EV charging infrastructure there. Those parking conversations are often really long, convoluted. It's very political because a lot of people, I think very unfortunately, think, oh no, we need to have parking in these buildings. We don't want to reduce it because we don't want people parking on the street. So it can take a long time to get the right type of minimum parking requirements implemented. And then you're not getting the chance to future-proof all that parking. So I would share that perspective, but broadly, very much in agreement that we should not be requiring so much or any parking, but where there is parking, it's very important that it be EV ready.
Thanks. I'm glad for hearing your thoughts on that. I definitely agree.
And one of the things I have heard from some of the municipalities who are exploring this is that they're kind of like, there is different circumstances from the minimum. So they were looking to kind of say like, well, there are other mechanisms that we can use to address the community concerns that these minimum parking requirements are kind of the modus for with regards to street parking. But the traffic kind of, the traffic plans that are also required as a development application process are one other mechanism to address kind of community concerns related to parking, street parking, that often are the reasons for these minimum parking requirements that take place within municipalities. So that's one of the things that many municipalities are looking for, is that they would remove some of the kind of minimum parking requirements, but there's other mechanisms to address the community concerns that these minimum parking requirements are the motivation behind these minimum parking requirements. Because, oh, go ahead. And Paul, if you could ask, have you seen some of that kind of the parking also not being sold in kind of other 905 jurisdictions? Because I think that's one of the other challenges as well that some municipalities were kind of addressing, is that, there's different ways you would kind of like on a transit oriented development location versus a non-transit oriented development location. So that's some of the other kind of areas that where municipalities were trying to understand, how do we address the outcomes that our parking requirements are aimed towards in these different types of archetypes of the development, in a transit oriented development location, not in a transit oriented development location.
Yeah, that's exactly it. And there's been a few other cities actually just recently, even New Zealand, I think just last week, in areas within transit-oriented nature, they've eliminated parking requirements. I know City of Toronto is looking at that. The province of Ontario is looking at specific things within 800 meters of transit. So it's really just a matter of parking requirements at the municipal level, kind of catching up to where the market is, so that, like we said, the right amount of parking can be tailored to that demand, and then making them all EV, that's fine too, as long as you're not oversupplying parking and oversupplying EV where there isn't any demand for that.
Perfect. All right, and if it's okay, I'll probably reach out to you, Paul, because I'd love to kind of get a little bit more of your insight.
For sure, thank you.
All right, perfect, thanks. So I want to thank you all for joining this webinar. Again, I'm going to send you all the links in an email, as well as Brendan's presentation, the links to the various reports that were identified during this webinar. I'm going to send you the PowerPoint presentation. Going to do a number of nags to you to try and gather some of the kind of additional questions that are kind of percolating in your head. And then we're going to be kind of coming back to you with regards to next steps, but from the different various stakeholders that we're going to be doing some outreach. And then being able to share the input from each of the different stakeholders with each other. Because if there's one thing I've learned, is that we all got to start talking to each other more and hearing each other's perspectives. And we actually are all in this together, and we all have to work together on this. So thank you so much for joining and for the interest in this report, and that we will continue the conversation and share this with you. Probably we're going to have another webinar probably in early December, just giving you a little bit more insights on the questions that came from the various stakeholders and the input from the various different stakeholders as well. So thanks, everybody. Thank you, Brendan, so much for all your hard work on the costing study and for the presentation and for helping to translate all of this for us. And thank you to all of you for joining and for your interest in this really important topic. So thanks, everybody, and have a great day.
Thanks all. Take care.
See you later.